The last method is called method of moment. We want to estimate the population parameter, but here is done differently. It's more mathematics and less with a graphical concept. We use what's called a moment generating function to find a specific function for the distribution we are studying and get the mean, variance, and so on. Let me show you. Notice the correspondence from the sample to the population. Each m is called moment. First moment, second moment, and so on. Nothing to do with mean, variance for now. Think about it as just m1, m2, m3, and so on. These are the formulas used at each level to go from the sample to the population or from the population to the sample. Just note that each side has its corresponding function. The moment generating function is given by the expected value of e to the xt. The first step is figuring out which data type is your distribution, if it's discrete or continuous. Let's look at an example. With a Bernoulli, we have a discrete distribution. So we use the probability mass function and multiply it by e to the xt. Since we have two outcomes in the Bernoulli, remember that n is equal to 1, so you throw the coin once and the experiment is over. So since we have two outcomes, either 0 or 1, we add both and get 1 minus p plus p times e raised to the t. This is our moment generating function. To get our first moment, we find its first derivative and plug in 0 for t to get p. To find the variance, we need e squared. We need the second moment. To get that, we differentiate the function again and plug in 0 for t again to get p again. So our variance from the formula is m2 minus m1 squared. In other words, p times 1 minus p. Let's look at another example for a continuous distribution. Same process. This one is continuous, so we use the integrating function in terms of x and multiply by e to the xt and get the moment generating function, lambda over lambda minus t. The first moment is the first derivative. Again, plugging in 0 for t, we get m1. Second moment is the second derivative. Again, plugging 0 for t, we get the second moment, m2. The variance is the second moment minus the first moment squared. So we get 1 over lambda squared.